You know, it seems completely impossible, right? I mean, we walk through air every single day and we barely even feel it. And yet, that same invisible stuff can lift an object heavier than a blue whale straight up into the sky. How? Well, the answer starts when we completely rethink what air actually is. So let's break down the science of how air becomes a literal force of nature. And that's the key, right there. That's the mental shift we have to make. Air isn't just nothing. It's a fluid, just like water. It has substance, it has real properties, and when you get it moving, it can exert some truly incredible forces. Understanding this one simple idea is the first real step to unlocking the entire mystery of flight.
And that's exactly what we're going to do in this explainer. We're going to deconstruct the total chaos of airflow into a few simple, understandable pieces, the building blocks of flight.
So here's our game plan. First, we'll really dig into why air is a fluid and what that means. Then, we're going to uncover the simple building blocks of airflow. After that, we'll put those blocks together to reveal the big secret of lift, and finally, we'll see how this exact same thinking is what powers the design of the most advanced aircraft today.
Okay, so Part 1. Air is a fluid. Before we can even talk about a wing, we have to talk about the air itself. And there are two absolutely essential properties we need to get our heads around. First up is density. Now put simply, this is just how much stuff, how many air molecules are packed into any given space. And this matters a whole lot, because the more stuff you have, the more inertia it has. It's the air's density that gives it the muscle, the oomph it needs to actually push back against a wing and create a real force.
And number 2 is viscosity. The easiest way to think about this is as the air's internal stickiness. It's the friction between all the different layers of moving air. And this stickiness is what allows a wing to literally grab onto the air as it flows past, letting it control the flow and ultimately create lift.
All right, let's jump into Section 2, Flow's building blocks. Now that we know air has real substance, we can start looking at how it moves. And this is where things get really, really cool. Because the whole idea here is that we can take something that looks totally chaotic and make it simple. And look, this isn't just some nice metaphor we're using. This is the core principle of modern aerodynamics. As the source material says right here, these simple flows are literal building blocks. By adding them together, we can mathematically describe the precise flow of air around pretty much any object, including a super complex airplane wing.
So what are these magical blocks? Well, there are really just 3 basic ones. First, you've got uniform flow. Just picture a perfectly steady, constant wind. Easy enough. That's block number 1. Second, a source or a sink. This is just a single point that's either pushing air out in all directions, kind of like a sprinkler, or pulling it in, like a drain. And third, a vortex. This is just air spinning around a central point. That's it. These 3 super simple ideas are all we need to build everything else.
Now for the main event. Section 3, the secret of lift. This is where we take those building blocks we just talked about and assemble them to create a force so powerful it can literally defy gravity. The magic really happens when our building blocks made a very specific, very special shape. You probably know it as the cross-section of a wing. In aerodynamics, we call it an airfoil. And its entire job, its whole purpose, is to organize that airflow in a very particular and very powerful way.
Okay, so here is the crucial step. When that uniform flow hits the airfoil, the shape forces the air to circulate around it, and we can actually model this circulation mathematically as a special kind of vortex, a bound vortex. Now, this isn't a real whirlwind you could go out and see. It's a way of describing the net effect of the air moving faster over the top surface and slower underneath. And the critical part is, this effect stays bound to the wing as it slices through the air.
And boom, here it is. This quote from the Kuta-Chukowski theorem, this is the secret sauce. This is the scientific payoff. It creates a direct mathematical link. That circulation we just described, when you combine it with the air's density and the plane's speed, it produces a force, a huge upward force. And we call it lift. So really, the secret to flight is just creating and controlling that circulation.
Okay, let's bring this all home in our final section and see how these simple ideas build into the incredible technology we use today. Section 4. Modeling modern flight. This is where we connect the dots from pure theory to cutting-edge engineering.
Remember how we said you can just add the blocks together? Well, here's a perfect example. If you take one source block and one sink block and you mathematically place them in a uniform flow, the pattern you get perfectly describes the flow around this smooth, oval shape. It's a direct, visible proof of how simple ingredients can create complex results.
And this is what that math looks like when you put it to work. I mean, yeah, this is some old-school Fortran code, but the philosophy behind it is exactly the same as what we use today. Every line of code here is basically adding and arranging those simple building blocks, sources, sinks, and vortices, to calculate the pressure and lift on a wing. This is the direct ancestor of modern flight simulation software.
Today, engineers use something called the panel method. What they do is take a complex wing shape and they break its surface down into hundreds of tiny, simple, flat panels. And then they assign a building block, like a tiny little source or a tiny little vortex, to each of those panels. By adding up the effects of all those little blocks, they can simulate the airflow over the entire wing with incredible accuracy. See? The building block concept is still right at the heart of everything.
So in the end, flight isn't some kind of unknowable magic. It's just an elegant system. It's about assembling simple, understandable pieces to create a truly extraordinary result. And that leaves us with one last question to chew on. If creating flight is really just a matter of assembling the right building blocks, what incredible new shapes are we going to design next?